Hello everyone. Let me begin with a simple thought. When you push a shopping cart gently, it moves slowly. But if you push it harder, it accelerates faster. Why is that? Clearly, there must be a connection between the force you apply and the acceleration of the object. Newton's first law explained what happens when there is no net force. A body either stays at rest or moves uniformly. But what if a force does act? That's exactly what Newton's second law tells us, how force produces acceleration and changes motion. To truly understand the second law, we need the concept of momentum. Momentum is defined as the product of mass and velocity. It is written as P equals m into v. Momentum is a vector quantity. It has both magnitude and direction. Imagine a truck moving slowly and a small car moving fast. Even if the car has more speed, the truck may have more momentum because of its large mass. That's why a truck is harder to stop than a car. Let's connect this to real life. A heavy vehicle requires more force to stop than a light vehicle at the same speed. If you drop a light stone and a heavy stone from a building, the heavy one is harder to catch, more momentum. A bullet, though tiny in mass, can cause damage because of its extremely high velocity. All these examples show that momentum is a crucial factor in determining the effect of force on motion. Now, let's state the law. Newton's second law says the rate of change of momentum of a body is directly proportional to the applied external force, and it occurs in the direction of that force. Mathematically, F equals delta P by delta T. That means force is the change in momentum divided by the time taken. If mass is constant, then momentum P equals m into v. So delta P equals m into delta v. Substituting, we get F equals m into delta v by delta t. But delta v by delta t is acceleration, a. So finally, F equals m into a. This is the most powerful and widely used equation in mechanics. Now, let's apply this idea to cricket. When a seasoned cricketer catches a fast ball, he lowers his hands while catching. By doing this, he increases the time of impact. Since force equals change in momentum divided by time, increasing the time reduces the force felt by his hands. But if a novice keeps his hands stiff, the time of impact is short, so the force becomes very large and it can hurt. Let's solve a numerical example to see this in action. Problem: a ball of mass 0.2 kilograms moving at 10 meters per second is stopped by a bat in 0.05 seconds. What is the force applied? Step 1. Initial momentum P1 equals mass into velocity, that is 0.2 into 10, which equals to kilogram meter per second. Step 2. Final momentum P2 equals 0 since the ball stops. Step 3. Change in momentum delta P equals 0 minus 2, which is negative to kilogram meter per second. Step 4. Force equals delta P divided by delta T, that is negative to divided by 0.05, which equals negative 40 newtons. The negative sign tells us that the force acts opposite to the motion of the ball. So the bat applies a force of 40 newtons opposite to the ball's direction. Let's recap what we've learned. Newton's second law connects force with the rate of change of momentum. It tells us that F equals m into a when mass is constant. Greater momentum or shorter impact time means greater force. This law explains why cricketers draw back their hands, why airbags in cars save lives, and why bullets, though tiny, can cause serious damage. So to sum up, force is not just a push or pull, it is the rate of change of momentum in the direction of action. I hope you now have a clear understanding of Newton's second law, the true backbone of mechanics. See you in the next session, where we'll explore Newton's third law, the principle of action and reaction, which governs everything from walking to rocket launches.